Today we will be in Chapter 2, Section 3, the multiplication property of equality. Our topic objective for this section is to use the multiplication property to solve equations. Chapter 2, Section 3, multiplication property of equality. So the first thing that we want to remember that the reciprocal of a number is the multiplicative inverse. And if you have forgotten what it means to be the multiplicative inverse, that is what you multiply a number by to give you the number 1. And we're going to do some examples just so that we can remember what a reciprocal is. If you need some further refresher, though, it's going to be back in Chapter 1 that we talked about this, specifically the section that we talked about fractions in. But let's do some examples, and hopefully this will come back to you. So we have the number 2, and we need to figure out what the reciprocal of that is. So the reciprocal is what we are going to multiply 2 by to give us the number 1. So I'll write that over here, times a blank equals 1. So what do you multiply 2 by to give you the number 1? It's going to be 1/2. So the reciprocal of 2 is 1/2. 2 times 1/2 equals 1. Okay? What about -3/5? When you're doing the reciprocal of a fraction, all you're doing is flipping it. So instead of -3/5, we would have -5/3. Okay? And then we have -1, and we need to get to +1. So what would we multiply -1 by to get to +1? It would just be -1. Okay, here's a helpful hint. The easiest way of finding the reciprocal is to think of all numbers as fractions and then flip them. So here we have the number 2, and so if we write that as a fraction, that is the same thing as 2/1. You can write any whole number as itself over 1. And so then to get the reciprocal, you would just flip it, which would be 1/2. And that's what we got up there on our example. You can see the same thing with -1. If we have -1 and we write that as a fraction, that's the same thing as -1/1. If you flip that to get your reciprocal, you're going to get 1/-1, which is the same thing as -1. So this is probably the easiest way to find the reciprocal of any number, is just make sure it's written as a fraction and then flip it. You're going to be using this all throughout this section to do the multiplication property. So let's do some examples. So, using the multiplication property to solve equations. This is what this whole section is really about, and this is what all your homework problems are going to look like. So, you're going to have, in this example, we have 9x equals 63. So, the whole point of these problems is to get the variable by itself. So, in this case, our variable is 9. So, we need to get that is x. We need to get x all by itself, but right now it has that 9 out front of it, so we've got to get that 9 away from that x. So in order to do that, in these problems, you need to get whatever's touching the variable away. So we're going to use our reciprocal, or multiplicative inverse, to get rid of that 9. Because if that goes to a 1 over here, then we're just left with x. So we need this 9 to go to a 1. So how are we going to do that? Well, we need to multiply by the reciprocal. So on the side, let's figure out what the reciprocal of 9 is. 9 is a whole number, so let's write that as a fraction, which would be 9/1. So the reciprocal would be 1/9. So we need to multiply that 9 by 1/9 to get it to go away. But here's the rule. What you do to one side, you have to do to the other. So that means if we are multiplying one side by 1 over 9, we have to multiply both sides by 1 over 9. So I'm going to write 1 over 9 times 9x equals 63 times 1 over 9. We're just multiplying both sides by by 1 over 9. So the 1 over 9 and the 9 is going to cause that to go to 1, which is why we're doing that. Because when you do that, then you're just left with an x equals, and then you get 63 over 9, which equals 7. So we get x equals 7. The last step of all of your problems should be to check your answer. So that means we'd plug in 7 wherever there's an x. So that would be 9x equals 63. But we just said our x is 7. So 9 times 7 is 63, and that equals 63. So that means our answer is correct. Our answer is x equals 7. Okay, let's do some more examples. Okay. Example number 2 says x over 2 equals 4. Now, I know fractions aren't everybody's favorite, but you're going to see them from here on out, so we got to get used to them. And one of the things you need to get used to seeing is like this problem where we have the x over the 2, and so a variable is part of our fraction, which can be confusing, but I'm going to show you how you can rewrite this to make it look like all of our other problems that we've had so far. X over 2 is the same thing as writing 1/2 x equals 4. Because if you were to combine these, that 1 times your x would just give you x, and then you just have the 2 on the bottom, which is what we have in the original line. So this is the same thing as this, but this 1/2 times x is a little bit easier to work with when we're trying to find the reciprocal. So that's a good thing to note. Now, we need to find out what is the reciprocal of 1/2. So again, we're going to write 1/2, and then to find the reciprocal, all you have to do is flip your fraction. So that would be 2 over 1, which is 2. So the reciprocal of 1/2 is 2. So in order to get that 1/2 away from the x, we have to multiply both sides by the number 2. So that means I have 2 times 1/2 x equals 4 times 2. 2 times 1/2 would just go to 1. And then 4 times 2 is 8. So I get x equals 8. Again, you want to check all of your answers. So anywhere there's an x in my original problem, I'm going to put in an 8. So it'd be 8 over 2 equals 4. 8 divided by 2 is 4, and that equals 4, so I got that correct. Alright, let's do another one. In this example, we have 2 over 3x equals 6. So I need to find the reciprocal of 2 over 3. So what am I doing here? I'm just flipping. So that would be 3 over 2. So I need to take both sides times 3 over 2. So that would be 3 over 2 times 2 over 3x equals 6 times 3 over 2. The 3 over 2 times the 2 over 3 is going to go away and give us 1. So that will just give us our x, which is what we wanted. And then 6 times 3 over 2 will give us 18 over 2. And if you reduce that down, you get 9. If you don't remember your fraction multiplication very well, you need to go back to chapter 1 and make sure you get freshened up on that, but I'll work this over here on the side just in case. When you have a whole number, you'd switch that to a fraction. So it'd be 6 over 1. And then you'd still have times the 3 over 2. And
And when you're multiplying fractions, you're just multiplying straight across the top and straight across the bottom. So that would give you 18 on top and 2 on bottom, which is what we had. Okay, so we get x equals 9. So again, I'm going to check my answer to make sure I got it correct. So I'd have 2 over 3x equals 6. And anywhere there's an x, I'm going to put in the 9. So it'd be 2 over 3 times 9 equals 6. So 2 over 3 times 9, that'll be 18 over 3 equals 6. And that'll be 6 equals 6. So we got the correct answer. Okay. Now, the reciprocal way is very, very nice, and it is a great way to think of these problems, but there is another way that you can think about these that kind of makes more sense to some people, and is how I usually actually do these problems. And I like to call this the opposites way. This is not like the specific term for this method of doing this, but I call it the opposites way. And it's another way to do these problems is to think about division. So the opposite, notice the quotations, of multiplication is division. So kind of like the opposite of addition is subtraction, the opposite of multiplication is division. And what do I mean by that? Well, let's do an example and you'll see what I mean by that. So we have 8w equals 3. So the way we were taught to do it is we'd find the multiplicative inverse of the 8 and then we'd multiply both sides by that. But what my opposites way says to do is whatever is being multiplied out front, we just divide both sides by that and it'll be our answer. So if this 8 is multiplying that w, I need to divide both sides by 8. And when I do that, that's going to be, my 8's are going to go away. They're going to cancel out and give me a 1. So that leaves me with w equals 3 over 8. And that would be the end of my problem. I'm not going to check every single one of these. And just to show you, the reciprocal way that we would have done that is we would have found the reciprocal of 8 is 1 over 8, because that would be 8 over 1, and we just flip that, and that would be 1 over 8. So we'd multiply both sides by 1 over 8. And when you do that, the 8's go away, and you're left with 3 over 8. So in this case, it doesn't really shorten the problem much, but if you were to somehow mess up and finding your reciprocal, then your answer would have been incorrect. So it's kind of nice sometimes to think about the opposites way. Let's do another example. Let's do 7s equals 21. So if we were doing the opposites way, the 7 is multiplying that s, so we would divide by 7 on both sides. The 7's would cancel, and that would leave us with s equals 3. Short, sweet, and simple. Just the kind of math we like to do. Alright. Example number 3 says negative x equals 72. Excuse me. So what is multiplying our x? Well, that negative is out front. And you can think about this as being negative 1 times x equals 72. Because we always just shorten it and just write it as a negative x, like on the top line, instead of writing the negative 1 times the x. But if you need to write it out until you get used to it, that's okay too. So if that negative 1 is multiplying the x, then that means we have to divide both sides by negative 1. So divide by negative 1, divide by negative 1. Those negative 1's on the left will cancel. So that leaves us with x equals a negative 72. Alright, let's go on. Here's a cautionary note. If there are fractions in your problem, I would recommend using the reciprocal method. And I will show you why with this next example. This next example says 2 over 3x equals 6. And that is the same example that we had earlier. And we found out that x equaled 9. I don't know how to get this on here. Here. It's the same example that we did earlier, and we got x equals 9. So that's the reciprocal method that we used. We found the reciprocal, we multiplied, and we got x equals 9. Okay, that one was pretty simple. So I will show you why I recommend using that method over the opposite method. Here, if we're doing the opposites method, we would be dividing by 2 over 3 because that's what we're multiplying by. So we divide both sides by 2 over 3. And hopefully me just writing it like this would show you why I don't like doing the opposites method with this. Because then you have a fraction within a fraction. And that can get really confusing really quickly. Our left side doesn't get that confusing because it's just meant to go away. And so we're still going to get x equals whatever. But on this side, written like this, we have a fraction beneath another fraction. So if I write it out side by side, I have 6 divided by 2 over 3. Now you have to be good with your fractions in order to do this using the opposites method, because when you divide by a fraction, you have to remember the rule is that you are flipping your fraction and then changing your sign from division to multiplication. So if you're not good with your fraction rules and you don't remember that, that's why this one can be harder this way. So you would get x equals, and then 6 times 3 is 18, over 2, which equals 9. So I mean, you get the same answer working it either way, but this way can get more confusing. So it's really up to you how you'd like to do it, but anytime that there's a fraction like that, I'm going to be using the reciprocal method instead of the opposites method. Let's do another example. Okay, we have negative 2x equals 3 over 5. So there is a fraction in this one, so I'm going to use the reciprocal method instead of the opposites method. So to the side, I'm going to figure out what my reciprocal of negative 2 is. Negative 2 is the same thing as negative 2 over 1. And when I write it as a fraction, then I can just flip it and get 1 over negative 2. So that's my reciprocal. So I need to take both sides and multiply them by negative 1/2. So I have negative 1/2 times negative 2x equals 3 over 5 times negative 1/2. So I'm left with x equals, and then 3 times negative 1 will give me a negative 3. 5 times 2 will give me 10. So I'm left with negative 3 over 10.
Okay, so let's do some homework problems. You need to get into the Course Compass site and get into your homework and click 2.3. And I'm going to work problems 9 and 10. So problem 9 says 5x equals negative 3 over 10. So we're going to work through that problem. 5x equals negative 3 over 10. So let's think of the reciprocal of 5. Reciprocal of 5 equals 1/5. So you have to multiply both sides by 1 over 5. So we have 1 over 5 times 5x equals negative 3 over 10 times 1 over 5. The 1/5 times the 5 will go away to 1, so we're left with x equals, remember when you're multiplying fractions, you just multiply straight across. So we have negative 3 times 1, negative 3 over 10 times 5, 50. So negative 3 over 50 should be our answer. Let's see if that's true. Go over here and type negative 3, 50. Check the answer. Well done. So we got that one right. Alright, let's do number 10. Number 10, I'm going to work two different ways. I'm going to work the reciprocal way, and I'm going to work the opposites way. So we have z over negative 5 equals 8. So let me write that out. We'll do the reciprocal way first. And that way you can see both ways and you can make a decision which way you like to use best. So we have z over negative 5 equals 8. Remember, when you have the variable on top, you can make it look like a fraction. So we're going to make it negative 1 over 5, z equals 8. Now the reciprocal of negative 1 over 5 is negative 5. So we're going to take both sides times negative 5. The negative 5 times the negative 1/5 is going to be 1. So we're left with z equals 8 times the negative 5 will be negative 40. So that's using the reciprocal way. Now I'll leave that one up, and we will also do the opposites in quotations way. I actually prefer the opposites way in this case, but I will let you pick. So we have z over a negative 5 equals 8. This negative 5 is dividing that z. So what is the opposite of dividing? The answer to that is multiplying. So if we are multiplying by a negative 5, or excuse me, if we are dividing by a negative 5, then to do the opposite of that would be to multiply by negative 5. So that means we just need to take both sides times negative 5. This negative 5 times that divided by that negative 5 is going to go to 1, so we're going to be left with z equals a negative 40. It's really the exact same problem. It's just in this case you didn't have to pull it out front and then think of the reciprocal. You just had to think of the opposite. So you can use whichever method you like, whichever method makes more sense. Sometimes you're going to probably use the reciprocal method, and other times you might use the opposites method. Either way is correct, and either way will work. Let's put in our answer. Hit enter. Fantastic, we got it. So those are going to be the types of problems you're going to see on your homework and on your quizzes for section 2.3. So good luck on your homework and good luck on your quizzes.